Okay, so today we're going to start Chapter 5, and Chapter 5 has to do with polynomials. I hope y'all remember that word from Algebra 1. Section 5.1, we're going to use properties of exponents. Now, y'all know what an exponent is. It's when you have a power, something raised to a power. So we got the little big number at the bottom, that's called the base, and the little number on top is called an exponent. So there's a whole list of exponent properties on page 330. So if you want to put a little note there that you can look there for these, and it also has examples, so it's a good little list to look at. I'm just going to try to summarize that list real quick. One property of exponent is when you multiply powers. If they have the same base, now remember base is the big number or the big variable on the bottom, you're going to add the exponents. So when we multiply two powers that have the same base, we add their exponents. So like x squared times x to the 5th is x to the 7th. We add the 2 and the 5. Okay. Then if we take a power of a power, that's when you have something that already has an exponent and you raise it to another exponent, we're going to multiply the exponents. Hopefully this is ringing somewhat of a bell from Algebra 1. It will when we work problems for sure. When we divide powers, when they have the same base, we subtract the exponents. If we have a negative exponent, you move the power. Now the power is the base and the exponent to the other part of the fraction. So if it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. And I think the last one we're going to talk about is if we have a 0 exponent. Y'all remember this one? Anything raised to a 0 power equals what? 1. That's right. Anything raised to a 0 power equals 1. And if you forget, you type something in your calculator raised to a 0 power. And to raise something for a power in your calculator, you're going to use the little rooftop button. I think it's under the little arrow pad. It's under the clear button, underneath the arrows over there above the multiply divide operations. So to raise a power in the calculator, you're going to use the rooftop. So just to test me out, type in 5 rooftop 0. Be 5 raised to the 0 power. And tell me that it equals 1. It does, don't it? Okay, so that's how you raise a power in your calculator. You hit the rooftop button, which is on the far right-hand side. So these are our exponent properties. And like I said, we learned them all in Algebra 1. And we're using them again here in Algebra 2 because we're talking about polynomials this chapter. And polynomials have a lot of exponents in them. All right. So what we're going to be doing for the rest of this lesson, pretty much for the most part, is we're going to do operations using exponents. And then at the end of the lesson, we're going to talk about scientific notation. So that's pretty much how the lesson's going to go. So let's start with example A here. X to the negative 4th power times x to the 6th times x to the 7th. So notice how those all have the same base, right? What is the base? X. So our answer will also have an x in the base. So what's being done mathematically to all those powers?
Multiply.
They're multiplying. And back for our exponent properties that we just talked about, if they multiply, we do what? Add the exponent. So we're just going to add negative 4 plus 6 plus 7.
9.
It is 9. So my answer to this is 9. And that's all you do. So if they multiply and they have the same base, you keep that base and add the exponents. Questions? All right. Let's do another simple one. X to the 3rd power raised to the 5th power. X to the 3rd power raised to the 5th power. Which one of those properties does it look like is going on right here? It's a power of a power. X to the 3rd power is already a power, and then we're going to raise that to a 5th power. And what are we supposed to do mathematically when we take a power of a power? Multiply the exponents, and you keep the base, and you get x to the 15th. So power of a power, you multiply the exponents. Okay, let's do another simple one. A to the 8th power divided by a to the 3rd power.
Joseph Cook, come to the front office.
A to the 8th power divided by a to the 3rd power. So what are we doing with these bases? They're dividing, and they have the same base, so we're going to subtract, right? Yeah, same thing. But I wanted us to know that they're dividing to start with, okay? So A is our base, and what is 8 minus 3? 5. In my class it is. All right, so they divide, they have the same base, you subtract the exponents. So any questions about those? So now what we're going to start doing is mixing all of our rules together. So the problems are going to get a little bit more difficult. This one says negative 4 times 2 to the 5th power all squared. Negative 4 times 2 to the 5th power all squared. Now the first thing I want you to notice is that everything is in parentheses and then there's a square on the outside. Okay? Everything is in parentheses and then there's a square on the outside. That means everything on the inside gets the square. Okay? So the first thing I want you to do is break everything up. So this is a negative 4 to the 1st power to start with, right?
So it's negative 4, another negative 4 squared.
So I'm taking a power here. Well, that's what those parentheses mean to do. So I have to multiply the powers. So 1 times 2 is 2, so negative 4 squared, times 2 to the 5th power squared is 2 to the what? 10. So if it already has an exponent, you multiply.
You have to put in parentheses?
I just do, especially with a negative. Because there's a big difference in negative 4 squared and then negative 4 squared with the negative on the outside. Because I actually have to square the negative. And anything squared is going to be a what? Positive. So negative 4 squared is positive 16. So your calculator lies on that. So don't rely on that calculator for that because it will lie.
How are you supposed to know?
You're supposed to know that a negative squared is a positive.
Oh, it'll get you the right number. Just tell you the wrong sign.
You'll tell you the wrong sign. Yep. And then 2 raised to the 10th power. You can do that rooftop button. What's 2 raised to the 10th power? 1,024. And then last you multiply that times 16. And what do we get? That's your answer. It is. Let's do another one like that one. Just to make sure. Negative 3 squared times 5, all raised to the third power.
3 times 2 is 6. So negative 3, 6 power.
Yep. So everything gets a third power. And if it already has a power, you multiply it. So negative 3 to the 6 times 5 to the third. Yes. So how do you know if your answer is going to be a negative or a positive when you raise it to a power? Because your calculator lies.
They're always positive.
Always
Unless
positive?
it's on that, that's negative on the outside.
Always positive?
Well, the positives are positives and the negatives turn positive, so.
What if it's like a prime number, or like just like 5 or
Okay.
something?
So what's the rule? We learned this in junior high. The rule is if you raise anything to an even exponent, it will be a positive. And anything raised to an odd exponent will be a negative. And that only works for negatives. So a negative raised to an even exponent will be positive. If it's to an odd exponent, it will stay a negative.
So if that 6 was a 5, it would be a positive number.
It would be a negative number.
That 6 is 6.
It is a
Okay.
6.
Positive.
It's positive. Yes.
We know.
Yes, you did. Okay. So let's just think about this. Don't write this down, okay? I'm going to do it in blue so we won't. So, okay. So, how many negatives do we have there? 1. What's negative 3 times 3? What's negative 3 times 3?
9.
Negative 9. What about this? What is that? Positive 9. Right? 1 negative is a negative. 2 negatives.
So if you had 5 negatives, it would make every other one would be negative, positive.
That's right. So say I got this going on. 3 negatives. Well, a negative times a negative is a positive. So these two make a positive. Right? Times a negative makes a negative. So that would be a negative 27. So you're right. So an odd exponent keeps it negative. An even exponent makes it positive. So every other one. Does that make sense?
Odd makes it negative.
Mm-hmm.
Even makes it positive.
Yes. Good job. See, we reasoned through that. So negative 3 to the 6th power will be a positive what number? Rooftop it for me. 729.
That means it's positive.
Mm-hmm.
Times 5 to the third.
Y'all know what 5 to the third is off the top of your head? 5 times 5 times 5.
5 times 5 is 25. Times 5 would be 125.
125. Yeah. So then it's 729 times 125. And what are y'all getting?
Big number.
How big?
1,000. 10,000.
91,125. Okay. So the main time, yeah, that was just some little number arithmetic from that way back when. But are we okay with the distributing of the exponents up here, of the exponent properties? Because that's really what we're trying to focus on today.
That's as complicated as it gets.
I didn't say that at all. Just hang on to your horses. Hold the reins. That's math for you. Let's do fractions.
Fractions with exponents?
Yes. 11 to the 5th power divided by 11 to the 8th power.
Hey, lay up again, come to the office.
All raised to the negative 1 power.
How can these be raised to the first power?
Well, anything to the first power is itself.
So just throw a negative in front of it.
No, you can't just do that, dear. So a negative exponent, okay, notice how that's outside the parentheses, right? And parentheses mean everything on the inside gets that exponent. And if it already has a power, what do we have to do?
Put a negative in front.
No. If it already has an exponent, what do we do?
Multiply that.
Multiply.
It'll be -5.
Yeah, but that's not what you always do. This one you do, not always. Over 11 to the negative. Now look back at your properties, and what does it say you're supposed to do with negative exponents? Move it to the other part of the fraction. When you do, you make it a positive. So this 11 to the -5 needs to go to the bottom and change to 11 to the +5. Okay? And this 11 to the -8 needs to come up to the numerator and become 11 to the +8. So you move it to the other part of the fraction.
And then we simplify.
Then we can simplify again because they have the same base and they're being divided. So what do I do when I divide two things with the same base? Subtract. So that is 11 to the 3rd. And we can evaluate that number. It's relatively
How do
small.
you know when to put that 8 on the back and when to put the 5 on the back?
We're on the back.
Like, how do you know? Why would that be a negative?
8 minus 5 equals +3. Top divided by bottom.
Okay.
So top minus bottom. So 11 to the 3rd power. Well, 11 squared is 121 times 11 more is how much? My calculator just completely died. 1,331. 1,331. Any questions on that one? Well, anytime you have a negative exponent, you move that one to the other part. We're going to do some more of those. Like this one. Parentheses 1 to the -4 power over 3 squared, all raised to the -2.
Two negatives make a positive.
Wait a second. Don't jump ahead. Yes, you're right. Two negatives multiply and make a positive. But I'm taking a power of powers here because I have a parentheses with an exponent out here. So everything gets a -2. So I multiply all the exponents I've got inside by -2. So that's going to make 1 to the what? -4. Okay. And the next thing we do is we change negative exponents to positive exponents. So how do I change negative exponents to positive exponents?
What if one of that? What's that one with positive?
Then you don't move it. Right, you move that -4th power up to the top. And so you're going to keep your 1 to the 8th on top. And you're going to put with it a 3 to the 4th power. And you're not going to have a denominator, so it's like being over 1. And you can leave off the denominator. So if there's nothing left in the denominator, you just put it like it's over 1. What's 1 to the 8th power? 1 times itself 8 times.
8.
Try again.
1.
1. Yeah, 1 to any power is going to be 1. And what's 3 to the 4th power?
3 times 3. 9 times 9 times 9. 40, 81.
81.
I was getting close.
You were. And 1 times 81 equals 81. Not so bad. Just takes practice getting good and comfortable with them. Let's do another one. Okay, let's do this one. Fraction again. R to the -2 over S. I hate S's. I should have changed it. S to the 3rd to the -3rd power.
R to positive 6.
Yeah, everything gets a -3. All right, say what you're doing. Everything gets a -3rd, right? So it's R to the positive 6 over S to the -9.
So how do you ain't got no numbers, so what do you do?
You got to move your negative exponents.
That was 9 and to the 9.
So leave r to the 6 alone because it's already positive and it stays on top. And s to the 9th goes on the top with it. And you can put it over 1, or you can leave it alone. Now, we don't have any like bases, do we? R and S are totally different bases, and there's nothing else you can do to simplify it. So your final answer is just r to the 6 times s to the 9th. That's all you can do. Mm-mm. You can put the dot there if you want to, or you can leave it just squished together, and it means the same thing. But that's all we can do because we had totally different bases. Now, if these were both S's or both R's, we would add them together. But since they're different bases, we leave them alone. Okay, let's divide.
Well, the scientific and all that stuff.
Yes, I told you that. All right, let's divide some. 16 m to the 4th n to the negative 5th over 2 n to the negative 5th. So the first thing we want to do on here is move our negative exponents. So this one's got a negative exponent and this one's got a negative exponent. So how do I make them positive?
Put the n times n.
So I got to move them both to the other part of the fraction, right?
Swap.
So we're just going to swap them. So the 16 m to the 4th is going to stay the same spot. The 2 on the bottom is going to stay in the same spot. I'm going to bring an n to the 5th to the bottom and an n to the 5th on top. Now we can simplify. Let's start with our numbers. What is 16 divided by 2, y'all?
8.
8. So for numbers that don't have exponents, you just divide them. 16 divided by 2 is 8. Now the m don't have any like bases, does it? No, so you can leave it m to the 4th on top. That's not going to change. What about these two? Same base, and they're divided, one's on top of each other. So what do you do when we divide two things the same base? Subtract. What's 5 minus 5? 0. What's anything raised to the 0 power equal? 1. So basically these two cancel each other out. So you cancel out the n's. If they have the same base with the same exponent, one on top, one on bottom, they cancel out. So my answer is this right here. That's it. I divided 16 divided by 2. The m's aren't changing because they don't have anything else with the same base. Let's do another similar type problem. Negative 14 x to the negative 3 y to the 5th over 35 x y to the 3rd. Now the first thing you want to do, if you don't have any parentheses, the first thing you want to do is move your negative exponents. So do we have anything with a negative exponent? This x on top. So that means you're going to move that x to the 3rd to the bottom and make it positive. So everything else is staying where it is, except for putting an x to the 3rd on the bottom. And I'm going to stick it where by the other x because those are like bases, aren't they? So I just stick it somewhere close to its like base. So all I did differently is this x to the 3rd is on the bottom now where it was a negative 3rd on top. All right, then we can simplify a bunch of things at once. First of all, these two numbers right here we treat like a fraction. So negative 14 over 35, what does that reduce to as a fraction? Yeah, divide them both by 7, don't we? So this becomes a 2, this becomes a 5. And remember it's negative, so we got to keep it a negative 2 over positive 5. Leave it like that. Look at these x's down here. They are being multiplied, so what do I do?
Add them x to the 4th.
Yes, so this is the x to the 1st, 3 plus 1 is 4th, and it's going to stay on the bottom. And what do you do with the y's? They're divided. One's on top, one's on bottom, so you subtract them. What's 5 minus 3? 2. And my rule for this is wherever the larger exponent was, that's where you need to put the leftovers. So it's kind of like the big kid at the table gets the leftovers. You know what I mean? Wherever it was the biggest exponent, that's one gets the leftover. So 5 minus 3 is 2. So y squared goes on top. And then when you're finished, look and make sure your numbers are simplified as a fraction. Or you could just put it a y squared on bottom. Because if you put a -2 on top, you'd have to put a y squared on bottom. So it's saving you a step. Big kid gets leftover, saves you a step. But then for your answer, make sure that your numbers won't reduce as a fraction anymore and that your variables are all different bases. And if that's the case, then that's your final answer. So you have your final answer when your numbers are simplified as fractions and your variables are all different. That's how you know you're done. So any questions on that one? Okay. Let's see another one that works slightly different. I'm just trying to give y'all a variety of everything I think you'll see. So you can't say, Miss Isbell didn't teach me that one. All right, this one really went with something we did earlier. So what do we do if we have parentheses with the exponent outside it? Everything gets the exponent, right?
4a to the negative 15.
Well, 4's in the parentheses, isn't it? Is 4 in the parentheses? It gets the exponent too. 4 to the negative third, okay? A to the what?
Negative 15.
That's right, you multiply them. And then B to the what? Positive 6. So any questions so far? Okay, so what do we do with negative exponents then?
Make them positive.
How do we make them positive? Yeah, move it to the other part of a fraction. Now, this one don't have a fraction, so guess what you're going to do? Yeah, now you got a fraction. So B to the 6 is the only thing staying up top, isn't it? So 4 to the 3rd's coming down. A to the 15th's coming down. And they don't have any like bases, but you can evaluate 4 to the 3rd power. What is 4 to the 3rd power? 4 times 4 times 4 is what?
4
Times 4 is what? 64. So B to the 6 over 64, A to the 15. And again, the A and B are different bases, so that's all you can do.
Would you count? We always have to simplify
The numbers, if it's a small something like that, now if it's to like the 1,000th and something power, probably not. But I usually don't count off, but just keep in mind that on multiple choice, you might see it either way. Does that make sense? Okay. I'm more worried about your variables. Okay. Let's see. A few more of these. J, K, L. I just want y'all to see everything that you're going to see on the homework for sure. M to the 3rd, N to the 3rd times R, not R, M to the negative 3rd, N to the 5th. Now, do these parentheses have an exponent outside of them? No. So if they don't have an exponent outside of them, it's not power of powers. You're just multiplying. Okay? So if there's no exponents right here, you're just multiplying. So combine your bases.
3m.
Wait a second. I like to do them in order. All right? So are there any numbers to go with 2?
Yeah, no.
So keep it 2.
Put that another m counts as. Wouldn't that make it 3m times 9?
Where'd you get it? No, it's 2 times 1. You don't add those, you multiply. Yeah, you only add the exponents. All right, so we can add the m's. What's 3 plus negative 3?
Negative
0, and m to the 0 makes 1. So we can leave off the m's because 2 times 1 is going to be 2, right?
Yeah.
And so now you do your n's. N to the 3rd times n to the 5th makes n to the what? They multiply, so we add and get n to the 8th. And that's your answer, 2n to the 8th. Questions? How are we gonna get good at this? We're gonna practice.
Perfect practice makes perfect.
That's right. Perfect practice makes perfect. So we're gonna do our best practicing. So hopefully we can get it perfect. X to the 5th, y to the 6th. That's a 5 right there. I can't make a good 5 today for nothing. What do y'all think we're going to do first here?
Correctly.
Not yet.
Another parentheses.
Parentheses, yeah. So that means everything on the inside of the parentheses gets a square. So that's going to be x to the what? -6. Power we multiply. Y to the what? +6. Over x to the 5th, y to the 6th. So, parentheses first. Guess what comes after parentheses? Negatives. Negatives. Right? Negative exponents. So, after you do your parentheses, move your negative exponents. How many negative exponents do we have? Just one. And we're going to move that to the bottom. So, we're going to keep. Yep. Y to 6 stays on top. I'll just stick it on front. Because we want to put our like bases together. So, what do we do with those x's? We add them and keep it on bottom. So, what's 6 plus 5? 11. And what about those y's? What do you get?
0.
And what's anything to the 0 power? 1. So, you divide them and you get 1. They cancel out, basically, mathematically. It's not x to 11th. X to 11th is in the denominator. So, well, 1 over. Yeah. So you can leave an empty denominator, but you can't leave an empty numerator. So if you have an empty numerator, stick a 1 on top. No, not even close. Because y'all ain't seen 1. Y'all be glad. You'll be glad. Like, yeah, y'all. Okay, what about this one? 2 more examples of this, then we got to do scientific, and scientific's really easy. Trust me, I did cut out a lot from what the book gave you. A squared. 3. It's not 3 times it, though. It's, okay, but you got to say what it is. It's a
3
squared.
times 2.
It's a squared to the 3rd power. Power of power, so you multiply.
A to 6.
Yes. So everything's getting a 3rd power. If it's in the parentheses, it's getting a 3rd power. So a to the 6th power. B to the what? Over. Don't forget the 2. 2 to the what? It's a 1 on it right now, right? So 2 to the 3rd. Good. A to the what? And B to the 6. What's your next step?
Start subtracting.
Not yet.
Throw your negative down there.
Yes. So first you do parentheses, then you move your negative exponents. Okay? So this is the only one that gets to move. So it's going to be a to the 6th. And y'all can go ahead and evaluate 2 to the 3rd power if you want to. 2 times 2 times 2 is 8. A to the 9th stays on bottom. B to the 6th stays on bottom. But I'm sticking a B to the 3rd down there with it. All right. So what do we do with the A's? Divide them, which means I do what? Subtract. Big minus small. 9 minus 6 is what? 3. Big kid gets the leftover. So where was it bigger at? On the bottom. So we're going to put the leftover A to the 3rd on the bottom. No, we'll leave the 8. A to the third. I said, yeah, A to the third's on the bottom. Yeah, we don't have nothing on there yet. And then the b's are being multiplied. So what do we do with exponents when they multiply? We add and get b to the what? 9. And since nothing is going to be on top, we put a 1. Y'all understand how the a to the third got to the bottom? You subtract bigger minus small, big kid gets leftovers. That's just how I've always taught my kids to remember it. It's a pretty easy concept. All right, one more. Because I gave you some of these on your homework, and I want to make sure that Miss Isabel showed you how to do everything. That's my job. X, y to the negative 1 over x squared y times 7x squared over y. I'm going to give myself some space because my little thing at the bottom. So this is multiplying two fractions, and we haven't done any of those yet, okay? But y'all remember from elementary school that when you multiply fractions, you go straight across. Numerator times numerator, denominator times denominator, right?
Can you have me bring the x and we'll make it x? Or a squared x cubed.
I'm multiplying across. Can you do what now?
Yeah.
Okay. And when I go across, I'm going to do my like basis. So on top, I have an x, y to the negative 1, a 7, and an x to the third. Do I have any like bases on the numerators? X's, and this is an x to the first, right? So multiply them across. I'm going to get a 7. X to the first times x to the third is x to the what? Fourth. And I'm going to copy that y to the negative 1. I'll move that in a second. Promise you. Now this y, and now I'm doing the same thing on the bottom, like bases. And the only ones that have like bases are the y's. And this is a y to the first. So I'm going to keep my x squared. And what's 1 plus negative 4? Negative 3. So I added across and did my like bases where they multiplied. I added the exponents. Is everybody good there? Now what do you think I'm going to do? Move my negatives, which is just the y's, are going to basically swap spots. So 7x to the fourth, bring a y to the third to the top, over x squared, y to the first goes to the bottom. Now what do you think I'm going to do? Divide my like bases, which means I'm going to subtract them, right? So 7 stays on top because it has nothing to simplify with. What's 4 minus 2? So do I put an x squared on top or bottom? Top, because that's where the big kid was. And then 3 minus 1 is what? So do I put y squared on top or bottom? Because that's where the big kid was. And it's a whole number, so I don't have to put it over 1. So it's okay to leave an empty denominator, but if you have an empty numerator, put a 1 in it. So that answer is 7x squared y squared. And that's really as tough as it gets, is when you have to multiply across. Sometimes you have to do it with parentheses and negatives. That one only gave us negatives. Okay. So the last thing I want us to talk about is scientific notation. Specifically multiplying and dividing with scientific notation. I know that y'all remember from a long, long, long time ago that scientific notation needs to look like this. You have one digit between 1 and 9 in front of a decimal, and you're raising it times 10 to some power, right? So you only have one digit past it on the left side of the decimal. So one number, 1 through 9 on the left side of the decimal. If it's not just one digit right there, you got to fix it to where it's one digit right there. So we're going to talk about that in a second. Also, times 10 to a positive power will be a number bigger than 1. And times 10 to a negative power is going to be a decimal number that is smaller than 1, right? So the whole point In scientific notation, it's to show numbers that are really, 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 really big and numbers that are really, 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 really small. Okay? These are used a lot in science. Chemistry, physics, biology, medical stuff. You're dealing with very, very large things like the distance to the moon in meters. And you're dealing with very, very small things like molecules and cells and stuff like that. So that's why scientific notation comes in handy, and that's why it's called scientific notation, because you use it a lot in the sciences. All right, so let's talk about multiplying and dividing with scientific notation. Let's do multiplying first. This is example P. 8.5 times 10 to the 7th times 1.2 times 10 to the 3rd. Now, multiplying scientific notation is really easy. All you have to remember is take your little numbers in the front and multiply them together. And then you're going to take your 10 and multiply them together, because the 10s have the same base, don't they? Yeah, 10s have the same base. So you're basically just rearranging and putting your like stuff together. So we're going to do the decimals and then the tens. So when you do the decimals, just type that in your calculator and tell me what it says. 8.5 times 1.2. What do you get? 10.2. Times 10 to some power. Now we just learned that when we have two things with the same base that are multiplied, what do we do with the exponent? Add them. 10 to the 10th. But our answer is not simplified. How is our answer not simplified? Yeah, we have to have the first digit on the left has to be a number 1 through 9, right? One digit, right? 10's too big. So I have to change this number to scientific notation. So to fix that number to be scientific notation, I want you to ignore the 10 to the 10th for a second. Don't scribble it on your paper. I'm scribbling on my screen because I can easily unscribble it. This number in scientific notation, I moved the decimal one time. It's 1.02 times 10 to the first power, right? Because it was bigger than 1 to start with. That's why it's a positive first power. So you fix that to be scientific. Then you bring down your 10 that you had, and then you combine your 10s again. So 1 plus 10 is what? So this answer is 1.02 times 10 to the 11th. So when you're multiplying scientific notation, you do your decimals, then you do your 10s, and then you make sure your decimal was in scientific notation. If it's not, move it one spot, fix that in scientific notation, and add that exponent back to your 10. That's how we multiply scientific notation. Let's do it. 3.4 times 10 to the 3rd times 2.8 times 10 to the 8th. So what do you do first? Yeah, I'm going to do this without writing down that step, because we can do that. So you do 3.4 times 2.8 in your calculator. And what do you get? Some of y'all have broke fingers or something. What's 3.4 times 2.8? 9.52. Times 10 to the, how do you get your exponent on your 10? You add the exponents on the 10s. What's 3 plus 8? 11. Is this answer in scientific notation, or do I need to fix it? It's already in scientific notation because I only got one digit. I'm done. That was nice. Yes. So, yeah, I was just doing that one to explain it. But, yeah, decimal times decimal, 10 times 10, and then fix the scientific notation if you need to. Okay? What if you have one like this? 5.8 times 10 to the negative 6 raised to the fourth power.
Multiply it by four.
You don't multiply everything by 4. No. Not everything. You raise everything to the fourth power, which is not the same as multiplying by 4. So, no, it's not. 5.8 times 4 is not the same thing as 5.8 to the fourth power. You do multiply the 10 exponent by 4, though. I will give you that. So you can do the rooftop button with your calculator. Everybody type that in so I can make sure the rooftop button works. 5.8 rooftop 4. 5.8 to the fourth power. What are y'all getting? A big O number. Tell me what that big O number.
1,131. 60.649.
Okay, we'll rate that to 6.65. Is that okay with y'all? Times 10 to the negative what? 4. Is that answering scientific notation?
No, ma'am.
No, it's not. How many times am I going to have to move my decimal? 3 times. To the left, 2, 3. And since that number started out bigger than 1, it's 1.13165 times 10 to the third power times 10 to the negative 24. So this, ignore the 10 to the negative 24 to start with. Change that to scientific. Is everybody okay with that? Then after you do that, add your exponents on your 10. So what's 3 plus negative 24?
21.
Negative 21. So the answer is 1.13165 times 10 to the negative 21. So if you have it to an exponent, the decimal number gets the exponent and the 10 gets the exponent. Okay? Let's divide a few and then we'll be done, I promise. 2.8 times 10 to the third over 6.4 times 10 to the 7th. What do we do when we subtract things or divide? I'll just say what it was. When we divide things with the same base, we do what with the exponent? Subtract. So that's what we're going to do with the tens. With the numbers, we're just going to divide in our calculator. Top divided by bottom. So y'all do that for me and do 2.8 divided by 6.4. Spit out that decimal to me. 4375 times 10 to what power when I subtract? We would put a 4 on the bottom, right? Let's just subtract them, top minus bottom. So 3 minus 7 is negative 4, right? So scientific notation, we don't have a bottom. Is that answering scientific notation? Can we have a 0 in front? No, it's got to be 1 through 9. So how do I fix it to have a 1 through 9 in front?
34.
Yes, and this number is starting out smaller than 1, so it's 4.375 times 10 to the negative first power. So if the number starts out too small, it's a negative exponent. If it starts out too big, it's a positive exponent. Well, we're adding them. Negative 5. So the final answer is 4.375 times 10 to the negative 5. We good? All right, y'all prove it to me. I want y'all to try this one on your own, and we'll promise I'll call it quits for next today. I made it fun with these. Try it. Get as far as you can. When you finish, go ahead and check it with somebody close to you. All right, what'd y'all get when you divided? The numbers, the decimals.
0.5.
0.5. 0.5. And what about the tens when you subtracted them? What'd you get?
Positive 2.
-7 minus -9 is the same thing as -7 plus 9, which is +2. Can you leave your answer like this, though? No. 0.5 is too small, so you move it over 1. And you get 5.0 times 10 to the negative first times 10 squared, which is 5.0 times 10 to the what? First. Raise your hand if you got 5 times 10 in the first. We're good? Questions? All right, you'll practice. Now, y'all, it seems like a lot because there's a lot of properties. I get it. But you've got to practice these properties to know how to do them. Page 333. And most of them won't take you long at all. 3 through 36. It's important that you know these because we're going to need these throughout the whole chapter. We'll probably have a quiz in a few days. It'll have these on there, and there will be a big chest at the end of chapter 5. Because chapter 5 is kind of got a lot going on.